Okie dokie. Today we're going to check out how to do the sum of any polynomial series. Let's get started here. Suppose we try to find the sum of k squared. That would of course be just 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared all the way up to n. So we're going to try to find the sum of this. The first thing we'll do is convert our series function just into a polynomial of x. We could keep it k if we wanted to, but I'll just rewrite it as x. You can use any letter you like. And what we're going to do is synthetically divide this polynomial by the numbers 1, 2, 3. Always the numbers 1, 2, 3, okay? When you synthetically divide, of course, you will have x squared will have a 1. There is no x, so it's plus 0 times x. That's why there's a 0 here. And plus 0 constant, which is why there's a 0 here. So this is called synthetic division, and you can look it up. The only difference between other synthetic divisions and what we're doing is we will always do synthetic division for when we find the sums of a polynomial series, always by 1, 2, 3, and so on. Whereas in other synthetic divisions, sometimes we use different numbers. But in this method, we will always do 1, 2, and 3. Okay, so let's synthetically divide. I'll assume that you will go find that out, but I'll show you real quickly how to synthetically divide. So again, these numbers come from this polynomial. These numbers represent this polynomial, and we will synthetically always divide by 1, then 2, then 3. Let's start with 1. You drag the 1 down. 1 times 1 is 1, and then you put the 1 right there. 0 plus 1 is 1. Then you multiply 1 times 1 to get this 1 right here. And 0 plus 1 will give you 1. Okay, so that's our first synthetic division by 1. Let's synthetically divide by 2, our result here. So we drag the 1 down, just like we drag the 1 down here. The first number you always drag down. 2 times 1 is 2, and we put the number here. 1 plus 2 equals 3. Then we'll take 2 times 3 is 6, put the number here. 1 plus 6 is 7. Okay, and I'll do one more just so we get this clear. I know I shouldn't be teaching you how to synthetically divide. I'll assume you probably know how to do that. But we'll synthetically divide by 3 now. Always 1, 2, 3, 4, 5, and so on. So we drag the 1 down, just like we drag this 1 down, and we drag that 1 down. We drag the 1 down. 3 times 1 is 3. Put that there. 3 plus 3 is 6. 3 times 6 is 18. 7 plus 18 is 25. So that's how we synthetically divide the polynomial x squared. Now we will always steal the numbers that go along a diagonal this way. So we'll need this number 0, this number 1, and this number 1 right here. And what we will do is we'll make something called a factor polynomial with these 3 numbers right here. The 0 will be associated with x to the 0 power. I will explain that these parentheses don't mean what normal parentheses mean. These are very special parentheses. I'll explain them in just a second. So this 0 comes from that 0. This 1 will go right here. There's the 1, x to the 1 power. And it goes, of course, x to the 0 power, x to the 1 power, x to the 2 power. The next one would be x to the 3 if there was, but there is no more diagonal there. And so this one, it goes right here, right there. So let me explain to you what these parentheses mean, actually by looking at this last island here. What these parentheses mean is you will put the 1 here, or whatever coefficient this is. It might be a 7, then put a 7 here, but it happens to be a 1, so we'll put the 1 right there. And then we will start with x, and then 2 with parentheses, this factor polynomial. This is not a polynomial like this polynomial. This is a function. That's why I labeled that as f, and we label this one as p, so you can distinguish the two. But the 2 here means start at x, and then make 2 houses. So we have one house and another house. And the next house will always be subtracted by 1. So if this was 3, you'd have x, start at x, and then you'd have 3 houses. So one house would be x, then it'd be x minus 1, and the third house would be x minus 2, and so on. So these parentheses don't mean this is x squared. X to the parentheses squared means start at x and make 2 houses where each next house is subtracted by 1 more 1. All right. Well, let's try to do it for this island here. I'm sorry I wrote these parentheses. We don't need these parentheses. These parentheses are important. These are not important, so I didn't need them. I just accidentally drew them in, so they're not necessary. But these parentheses are very necessary. So what does this mean? Well, this 1 goes right in front. If this was a 5, then you'd put a 5 right there. Then we'll look at this parentheses 1. What does that mean? It means in a factor polynomial, when you transform a polynomial into a factor polynomial, this means start at x and then have only one house. Well, I already have the one house x, so I'm not going to do what I did over here with the 2 houses, x and x minus 1. So this means this. Of course, if you have 0 times this, that's the reason we don't have really an island here, because we'd have 0 times whatever, and it would not be necessary. So if we want to change a factor polynomial, if we want to change a polynomial function into a factor polynomial, we have to synthetically divide like we did here. If you want to change a factor polynomial into a function, back into the function, you don't have to synthetically divide. You just have to follow the rules that I did here. And notice now the question is this plus this equal to the original function? Well, of course, yes, it is equal to the original function, because here you get x squared minus x, and the minus x will cancel this thing, and so these people become x squared. So this was just a check to make sure our factor polynomial was correctly transformed from the x squared regular polynomial up there. So this is the first phase of trying to find the sum of a polynomial series. The next thing we'll want to do is we'll want to do the integral of the polynomial, the factor polynomial. So what is the integral of this factor polynomial? Well, of course, the integral of x to the parentheses 1 is x to the parentheses 2 divided by 2. And then this will be, the integral of this will be x to the 3, which I wrote here, x to the 3 divided by 3. So we need to integrate the factor polynomial, not the function polynomial, but the factor polynomial. This was just a check to make sure this was correct. We're not going to use this right here. So what is the integral of the factor polynomial? I think it'll turn out to be this. We'll call this Mr. Big F, not Mr. Little f. We'll call him Mr. Big F. And the formula for all sums, the sum is equal to the sum of this. The sum is equal to big F of n plus 1 minus big F of 1. What does that mean? Well, that means stick n plus 1 into here. I did that right there. Stick n plus 1 into this here. This is the function. Stick n plus 1 into these two. And I did right there. There, I stuck it in there. So this, with n plus 1 stuck in, is right there. minus, and here's our minus, and now always stick in 1. Always stick in 1. This works for all things. So if this was k cubed, or k squared minus 7k, or k cubed plus 5k plus 22, you would always have this as the formula for that. This would always be 1, and this would always be n plus 1. So this formula is for all sums. This formula right here is for this particular sum right here. So we'll stick 1 in here, and I did that right there. And we'll stick 1 into here, and I did that right there. Notice we have to keep the parentheses because those are very important. We'll see on the next step why they're so important. So we want to convert this from a factor polynomial sum into just a regular sum so that we can figure out what this is. So let's transform this. Let's see how we transform this. Remember the parentheses mean start at this house, n plus 1, and then make 2 houses. Well, I made 2 houses, but every house next has to be this house minus 1. So n plus 1 minus 1 is n. So that's the house there. So these people are these people. That 2 is this 2 right here. Let's try this one right here. Now, what does the 3 mean in parentheses? What does the factor polynomial with parentheses mean? It means start at this house. I did start at that house. There's n plus 2. And then go down by 1. So, I'm sorry, n plus 1. Sorry, not n plus 2. I started at n plus 1. Here's the n plus 1. And now I want you to make 3 houses, but subtract 1 from each one. So n plus 1 minus 1 is equal to n. We have to make 1 more house, and n minus 1 is n minus 1. So that's what the parentheses 3 means, is make 3 houses, start at this house, and then subtract 1 for each next house. That 3 is right there. Now we got to do this, and this is why this is also important, is because this does not mean 1 squared. What this means is start at 1. I did start at 1. Now make 2 houses. So I'll start 1. The first house will be 1. The next house will be 1 minus 1, because the next house always, you have to subtract 1 from the first house. So 1, and you multiply, of course, like I multiplied here, and I multiplied all 3 of these houses. When you multiply 1 times 0, of course you get 0. Whereas if you thought this was 1 squared, you would have written 1/2, and we would have gotten the wrong answer. So this does not mean 1 cubed. Parentheses is some strange mathematical symbol that tells you to start at 1. Here I started at 1. And then now this time make 3 houses. But subtract 1 from each one to get the next house. So 1 minus 1 is 0. 0 minus 1 is negative 1. And so here, of course, these are all multiplied, just like these 3 houses were multiplied. And 0 times all of this will also give us 0. This will not always work out to be 0, but it did in this case. Okay, so this has been transformed from, this is not the sum. This is the sum in terms of factor polynomials. We need the sum in terms of regular polynomials. And so we find out that the sum, if these 2 turn into 0, are just these things right here. And if you do a little bit of algebra on those 2, this is the answer for the sum of this. But if you do a little bit of algebra on this by taking n plus 1 out and then adding the fractions, you'll get this for the sum of k squared. Well, like I said, you don't just have to do k squared. You can also do k cubed with this method. You could also do 7k squared minus 5k plus 11. So you can do any polynomial. If the sum of these, the sum of any polynomial can be done with this method. It's just, if there's more terms, of course, or it's a little bit more difficult, some of this algebra will be a little bit more difficult. Well, I hope you enjoyed this lecture, and I look forward to any comments at the bottom. Thank you very much.